In this video, we're going to take a look at some of the questions involved in Algebra Revision 9. Each of the questions in this revision sheet asked us to rearrange it to get a new focus on the equation. So in this example, we're being asked to express it in terms of L. So we're looking to reverse all of the processes and get L on its own. So the first one that I can see that is easiest to remove is this 2 pi multiplied by it. So we're almost going in the reverse PEMDAS order here. So we're actually starting at the end. If there was addition, we would do that first. Subtraction, we would do that, and then we'd look at multiply and divide. So I'm going to do the multiply. How do I undo multiplication? Well, I'm going to divide. So I'm going to divide by 2 pi, and then I'm going to get it's equal to the square root of L over G. The next thing then I'm going to have to target is that square root, and I'd ask myself, how do I undo a square root? Well, the opposite of square rooting something is squaring it. So I'm going to square everything here, and what we will find is that the square root and the square undo each other. So then we're left with L all over G, and then here I'm going to have t squared all over 4 pi squared. So you square the top, you square the bottom, and on the bottom we have to square the 2 and the pi. So we're almost there now. I've got L divided by G, so I need to ask myself, how do I undo that division by G? And the opposite of division is multiply, so I'm going to multiply up by G. And I'm going to get t squared multiplied by G all over 4 pi squared is equal to L. And there's the first expression rearranged to give us L. In question 2 here, we're being asked to express the equation in terms of u. So again, we're looking at undoing the process until we get u on its own. So here, the first step, I want to get rid of the square root, and to undo it, I'm going to need to square both sides. So that will leave me with v squared is equal to u squared plus 2as. Here then again, remember we're kind of working backwards from the PEMDAS rules, so I'm going to actually deal with that addition and subtraction first. So how do I get rid of an addition? I need to subtract it. So I'm going to have v squared minus 2as is equal to u squared. Then I'm going to ask myself, how do I undo something that is being squared? The opposite of squaring something is square rooting it. So I'm going to square root both sides, and those two things will undo each other, or it'll do it and undo it again, so we're just left with u, and then we get u is equal to v squared minus 2as. Question 3 here, we're being asked to rearrange the equation to express it in terms of or. So we want to get or on its own. So we're going to look at undoing everything around it. So I've got this 1/3, and it's 1/3 multiplied by all of that. So if I want to undo it or get it away from the or squared, I'm going to need to reverse it. So multiplying by 1/3, well then I could divide by 1/3, or another way of saying divide by 1/3 would be to multiply by 3. So I could multiply both sides by 3 here, and I will get pi r squared h. The next thing I need to get rid of is the multiply by pi, and I'm left with r squared h is equal to 3v all over pi. After that then, I'm going to have r squared by h. I want to get r on its own, so I'm going to get rid of the h. And how do I get rid of it? I'm going to undo the process of multiplying by h, which means I'm going to need to divide. So I have 3v, and then it's going to be pi all over h. And then finally, the last step, that's not or on its own. I need to undo the square root. And how do I do that? The opposite of squaring something is square rooting it. So I'm going to have the square root of r squared is equal to the square root of 3v all over pi h, and then these two will square it and then square root it, so it just becomes r. So there's that one rearranged to give us. In question 4 here, we're being asked to express it in terms of b. So again, we're going to go with the reverse of the PEMDAS order. So I'm going to deal with the addition here. How would I get rid of an a that's being added on? I need to subtract it. So subtract it from both sides, and I'm going to get c over d minus a is equal to b cubed. How do I undo a cube? If I want to reverse cubing something, then I'm actually going to cube root it, and it looks like this, the cubed root of the other side as well. Remember, whatever you do to one side of an equation you must do to the other, and I'm going to get that, and then when I have the cubed root here, it will do it and undo it, so I'm just left with b is equal to the cubed root of c all over d minus a. Finally, for the fifth question on this revision sheet, we were asked to express in terms of f, so it's just manipulating it in such a way that we get f on its own. The first thing I would do here is start to get rid of those fractions. So I'm going to say, how would I go from having 1 divided by u to not having any division by u? Well, I'd have to multiply everything through by u, and then I would have 1 plus u all over v is equal to u all over f. Next, I would ask myself, how would I get rid of that v, that divide by v? I don't really like it, so I'm going to say multiply because it's being divided. And if I do that, I'll get v plus u is equal to, and then it's uv all over f. And then in this scenario, I'm going to be now looking to get rid of the f, and I do the exact same thing. So I'm going to have everything multiplied through by f, and then I have this set up. Now the goal, if we remind ourselves, was to express it in terms of f to get f on its own. So looking at these two, they have a common factor, and that common factor is f. So I'm going to have f, and it's going to be v plus u is equal to uv. And then I'm going to have f on its own. If I want to get rid of that, I need to undo it, reverse the process. It's currently multiplying, so what I need to do is divide. And that's my final answer. F is equal to uv all over v plus u.